Two AI agents get the exact same task. Look up a flight and tell me the price. One agent finishes in 3 tool calls and gets it right. The other flails through 16 tool calls and still gets it wrong. That is not a hypothetical. It is a measured benchmark result. So today, we are running a real benchmark showdown on what happens when an AI uses a tool, because the gap between a winning agent and a losing one comes down to one mechanic hiding in plain sight. Round 1. The mechanism. Here is the part that surprises people first. According to Anthropic's own documentation, the model never executes anything on its own. It emits a structured request, and your code runs the operation. Think of ordering at a restaurant through a service window. The AI is the customer. It writes an order ticket. Get weather, city equals Boston. It slides the ticket through the window. It cannot walk into the kitchen. A separate piece of software reads the ticket, runs the real function, and slides a plate back. Only then does the AI answer you. OpenAI's function. Calling docs describe the identical shape. Your backend does the execution, never the model. That round trip is a minimum of 2 full passes through the model before you get an answer. Round 2. The invention that made this reliable. Before this became standard, models mostly reasoned in free text, and free text hallucinates. The fix came from a 2022 paper called REACT, short for Reasoning and Acting, from researchers at Princeton and Google. It forces the model to interleave thought, action, and observation, so every reasoning step has to respond to something a real tool actually returned. The paper measured it. Plain chain of thought had 14% of its wrong answers caused by outright hallucinated facts. Ground every step in a real tool result, and that dropped to 6%. And among total failures, 56% of chain of thought's failures were hallucination-driven. For tool-grounded reasoning, 0%. Round 3. Weak models versus real APIs. So tools should fix everything, right? Not automatically. A benchmark called API Bank tested this on real APIs. GPT 3.5 got simple, single-step tool calls right about half the time. Smaller open models, Alpaca and ChatGLM, landed around 20%. And accuracy did not just dip as tasks got longer. It collapsed. Add one planning step before the tool call, and effectiveness dropped roughly 21%. Add a second, and it dropped another 17. Every extra link in the chain is another place to fail. Round 4. The actual showdown. Here is the number that should be the headline. A 2026 benchmark called SciAgentGym tracked something nobody usually measures. How many tool calls each model actually needed. Weaker models averaged 16.55 tool calls per task and landed 23.4% accuracy. GPT-5 averaged just 3.41 calls and hit 41.3%. Same tools, same tasks. The losing model was thrashing, calling tool after tool to shave off its own uncertainty and getting worse results for the extra work. More tool calls is not a smarter agent. It is very often the opposite. Round 5. The twist. Even a model that picks the exact right tool can still lose here. Picture calling directory assistance and confidently reading out a phone number you made up. The operator dials it. Someone answers. That is a documented tool use failure mode. The model invents a plausible-looking parameter, an ID, a date, a file name. The tool runs successfully on that fake input and returns a clean, valid, completely wrong result. Nothing in the pipeline flags it because technically the tool worked exactly as designed. Round 6. Even the champion loses. A 2026 benchmark called ToolFailBench ran 1,000 tool tasks across finance, medicine, law, and cybersecurity against 19 leading models. The best model in the entire field only reached an 86.33% clean tool use rate. No skipped tools, no ignored results, no invented output. That means even the champion still stumbles roughly 1 time in 7. So next time an AI assistant tells you it booked something, Remember what actually happened. It wrote a ticket. Software you never see ran the real operation, and the result came back through the window. Whether that round trip took 3 tool calls or 16 was never about effort, it was the entire scoreboard. Follow Compile for what's under the hood.